everyone! My name is Emmy and I'm from the Prince George's County Memorial Library System, and we are all set today for STEM at Home. Who is ready to learn about some science? Raise your hand. Awesome! It looks like we have lots of scientists out there today who are ready to go. We are going to do some science experiments today that have easy materials that you will be able to find in your house, and you should be able to do that right at home on your kitchen table. And we're also going to be learning about some scientists from the past who made some really awesome scientific discoveries, and we'll do our experiments based on what they learned. So we're going to learn about Alice Ball, who was a chemist. We're going to learn about Annie Easley, who was a rocket scientist, and we're going to learn about Patricia Bath, who was an eye doctor. And all three of these scientists were Black women who faced a lot of obstacles because of the color of their skin and because they were women. They faced a lot of people who told them that they couldn't do what they really wanted to do, but all three of them were really passionate about science and math and about helping their communities with their scientific discoveries. So they worked extra hard, and they were able to make some excellent achievements and discoveries that we are going to learn about today with our experiments. So let's get started with our first scientist. We're going to talk about Alice Ball, first of all, and let's learn a little bit about what she did in her life and her work. In 1915, Alice Ball became the first woman and first Black person to graduate from the University of Hawaii. She was also the first Black woman chemistry professor at that university. At the time, there was a public health emergency. Many people suffered from Hansen's disease, also known as leprosy. A possible treatment that scientists were looking into was oil from the chalmugra tree. The problem with this oil was that it was very difficult for the human body to absorb it, and many patients' bodies rejected the oil before it could help treat their disease. Why was it so difficult for a human body to absorb this oil? Well, the human body is more than half composed of water, and it is very difficult for oil and water to mix with each other. So we're going to do a little experiment right now to demonstrate what it looks like when oil and water are mixed. So here's our experiment setup for experiment number 1. You want to make sure that you have a nice flat surface. And I have a little mat down because we are going to be using some liquids in our experiment today. So you just want to make sure that your surface is safe and covered. The first ingredient that you need is water. So I have my water in a little container here. This is just plain tap water, and you can use any container you want to keep that in. The second ingredient that you need is vegetable oil. I just have plain vegetable oil here, but really any type of oil will work that you have handy at your house. You can also use canola oil or any other type of oil that you already happen to have. The next ingredient that you will need is a plastic water bottle that has a top that's able to be sealed. So I'm reusing here a bottle from some iced tea. You can also use a reusable bottle and just make sure to wash it afterwards, but just use whatever bottle that you happen to have on hand. And these 3 ingredients are all that you need to do the experiment. I'm going to talk now about some ingredients that you might wish to have, but they are completely optional. One thing that you might wish to have is a funnel to help make the pouring of the liquids easier. I actually don't have a funnel in my house, so I'm going to be very careful with my pouring and just not use that object, but if you have one, you are welcome to do it. Another optional ingredient that you may wish to use is food coloring. This makes it a little more fun and easy to see the oil and water while they are separating in their container. So I have some food coloring here. I'm going to demonstrate the experiment both with and without the food coloring so that you can see what it looks like both ways. I also have a mixing bowl here for mixing the food coloring with the water. But again, that is optional. You don't need to use that if you don't happen to have those ingredients in your house. And with that, we are all set to start our experiment. So as I said, I'm going to be demonstrating this with and without food coloring. So I have a second plastic bottle here so that I can show you what it looks like with both ways. First thing you'll want to do is take that top off of your bottle. So that's what I'm doing here. And then we're going to slowly add the water to fill up the bottle halfway. This is not an exact measurement, so you can just go ahead and fill that until your bottle is roughly halfway full with water. As I said, I don't have a funnel with me, so I'm just going to pour that water very carefully and just measure to make sure that I have just about halfway of that bottle full up with water. And now here I have my second bottle If you're using food coloring, you can go ahead and fill that bottle halfway with water as well, just as you would if you weren't using it. And just a little more to make sure it's exactly halfway full. And then I'm going to very carefully add just 1 drop of food coloring to my bottle. So I'm using blue here. And we really only need 1 drop to fill up that because it's pretty powerful stuff. So I'm adding that 1 drop of food coloring. It looks pretty cool when you're adding it. And then we're just going to very tightly close the cap of that bottle and then swirl it around a little bit to mix. As I mentioned earlier, if you have a mixing bowl with you, you can also mix the water outside of the bottle, but I chose to do that right within our bottle there. Okay, then our next step is to add the oil, and we're going to do that to both of our bottles here together. And so again, this is just regular vegetable oil. Unfortunately, you won't be able to reuse this oil afterwards since we're using it for a science experiment. It's not really a good idea to let food and science mix, but this oil is fairly inexpensive that I'm using. It's just normal vegetable oil. So there I am, I've poured that into the bottle, and already we can see that the oil is settling at the top, and all of that at the bottom there is the water. Now there's a little bit of mixing going on, but you'll see over time that is going to be separating itself. And the reason why I had the mixing bowl here is I did try to mix food coloring in with the oil, and it actually did not work for me. So you are welcome to try that at home if you'd like to have some colored oil, but I wasn't able to get to the mix very well. So I'm just using the oil on its own, but as you can see, it's still very clear to see where the water ends and where the oil begins. So now we have both of our bottles here, one with food coloring and one without. And you can see there's a very clear separation between the two. The oil is right at the top there and the water is at the bottom. So now we're going to make sure that our lids are very tightly closed, because for this next step, you need to pick up your bottles and shake them so that the oil and the water are going to try to mix with each other. So I'm going to do that right about here. We're just going to pick up both of our bottles and we're going to swirl and mix them to make sure that it gets nice and all mixed up together. So now look at that. To our eye here at this time, it does look like the two have been mixed together pretty thoroughly. So now what you'll want to do is just leave those bottles to rest for a few seconds and observe what you see happening over time. So we're going to make sure to ask ourselves, what do you see happening as you watch your bottles? Do you see the contents of the bottle start to separate? And maybe just think to yourself, why do you think this is happening? Why are the contents separating? As you can see, this is already starting to happen. We have lots of bubbles rising up to the top, and you can see at the bottom it's much more clear as the water is separating itself out from the oil. The same thing is happening in our second bottle, and you can see it clearly illustrated because of the colors. So at the bottom we have a much darker blue because that's what we used with the food coloring, and then at the top it's getting lighter and lighter as the oil is separating itself out. So I'm just going to leave those to rest for a little while longer, and we're going to continue to observe. So let's think a little bit about why this might be happening. Both oil and water are made up of very tiny particles called molecules. And these molecules they both have a unique individual structure that makes it so that they can interact with other particles and molecules. And so some types of molecules do mix very easily with each other because they have a very similar structure. However, the structure of oil molecules is very different from the structure of water molecules, and that makes it so that they do not get along very easily with each other. It's very difficult for them to mix. So even now we can see a much more clear divide between the two. Even though we shook them around and mixed them, they were able to separate themselves on their own because they do not play well with each other. So this brings us back to the question of Alice Ball and her science experiment. Remember, she was trying to use this special type of oil from the chalugra tree to cure a disease. She had to think of a way to get over the problem of getting the oil to mix together well with water, because we know that humans are made up of almost 50% water or more. So what Alice had to do was to come up with a way to get those two to mix. Let's talk a little bit more about how she did that. So what Alice Ball did was invent a a special method of altering the structure of the chamugra oil to make it so that it could mix more easily with water, but still treat the disease. And so her method, no one had ever found out a way to do that before, and she was the first one to discover it. Unfortunately, a white professor from her university stole her idea and published it as his own and said that he came up with it. And it wasn't until years later that some people worked hard to get her credit for her own work. And today, that method that she invented is known as the ball method. So that's important to remember. If you ever see someone taking credit for someone else's idea, it's really important to speak up so that the person that really made the discovery gets their own credit for that. Our next scientist today is Annie Easley. She was one of the first rocket scientists to work at NASA. So let's learn a little bit about what she did. Here we go. So in the 1940s, Annie Easley wanted to work in a pharmacy, but the program at her school shut down. So she decided to study math instead. She went on to get a job at NASA working as a computer. So back in those days, we didn't have mechanical computers, so real people had to do all of the math problems that a computer would do and solve them by hand. Eventually, NASA did go on to get actual mechanical computers. These were huge machines that were as big as an entire room. And because Annie had been working so well as a mathematician, she went on to be a computer programmer. And she ended up working on one of the first navigation systems for a rocket, and it's been used on hundreds of rockets and satellites since. After she did her rocket work, she went on to research and develop alternative energy technologies with NASA, including solar winds and electric batteries for cars and vehicles. Her research led to the development of some of today's hybrid cars. So because Annie Easley worked at NASA on spaceflight technology and alternative energy, we're going to go ahead and make our own flight vehicle that operates on a source other than fuel. So we're going to make our own hovercraft today, and you're just going to need a couple of ingredients to make that. And I have them all here for you. The first thing that you're going to need is a disc, such as a CD. Now make sure this is a really old CD that you don't want to use anymore. And if you don't have anything like that in your house, you can also cut a circle out of some stiff cardboard. Just want to make sure that it does have a hole in the middle like a CD would. That is crucial to the construction of our hovercraft today. The second item that you need is a water bottle lid that can open and close. So this is a lid from a reusable water bottle. It does have that stopper that can open and close, so we can make sure that it's sealed, but also when it's open, that air can travel through the spout. If you don't have a water bottle lid like this, you can also reuse a lid from something like a shampoo bottle. You just want to make sure that it does have that open and close mechanism. So here's an example of something like that. It has a hole for air to pass through, but it also has a lever that allows us to close that lid and make sure that it's sealed. The next ingredient that you're going to need is some tape. We'll be using the tape to attach the pieces of our hovercraft together. So I'm using a strong Scotch tape. You can also use some glue if you would prefer, but that does make the experiment take longer. You'll also make sure that you need to have a balloon, so I'm using one of those. And that is just about all that we need to construct our hovercraft. So the first step is to attach our lid that can open and close to our round disc, such as a CD. So I'm going to use some of this tape to do that. Something that you're going to want to keep in mind is that while you're attaching that lid, you don't cover up any of the holes. Here I am having some trouble with the tape. This is all about scientific trial and error. There we go. So we have a hole in our disc, and that is really important to make sure that it's left open so that air can travel through. So what I'm going to do is take my water bottle lid and place that directly over the hole. That way when the lid is open, the air can travel through the top and it can go through the bottom. At this time, my water bottle lid is closed. I'm going to be opening it later, but now is not the time. And so here I am attaching this to the tape. As I said, you can use glue or hot glue to do this as well. And I'm wrapping that tape around the underside of it. You just want to make sure also that it's very flat. There's no wrinkles under the tape because that will interrupt the flight of our hovercraft later on. So the bottom needs to be smooth. That hole at the bottom of your disc needs to be open and unencumbered. and we are all set to move on to the next stage of our construction. I have that firmly attached. This does have the ability to open, but right now we want to make sure that it's closed so that none of the air escapes. So now, I have our balloon. I'm going to blow that up, but you don't want to tie it at this time. You want to make sure that the spout of the balloon is open. So we have the balloon, and I am going to wrap that around the spout of our water bottle. So you want to use one hand to pinch the balloon, make sure that none of the air escapes, and with your other hand you can attach that so that it's wrapped completely around the top of that water bottle spout. And this is our hovercraft. Our construction is now complete. We're going to do a test flight for this now, and I'm going to show you how it works. So you'll need a wide flat surface. Make sure there's no obstacles for your balloon, because it will kind of move about the space as we go. Let's take a look. I think we're ready to test it. So now that we have our balloon and our flat surface, you just want to make sure that your balloon is still over that spout, and then you want to open it so that the lid is exposed, and there it goes. Now it's traveling on its own. And you are welcome to kind of give it a little bit of direction. You can bat it around. It works a little bit like an air hockey disc, and we're going to talk about how that works in just a second. I did make a second balloon hovercraft with the other type of lid so that you can see how that one works too, and this one actually for me worked a little bit better. So if you do have a shampoo lid at home, you may want to try that one out. But as I mentioned before, this sort of looks like an air hockey disc when you're giving it some direction and batting it around. And it actually operates in exactly the same way. So we have a flow of air that is moving from the balloon. So the balloon is full of your own air that you've blown into it. And it's moving through that cap when it is open, out the bottom of your disc. There's a hole in that disc that allows air to travel through it, and then it provides kind of a cushion of air that lets the balloon travel on its own. And so this is a vehicle that operates without the use of fuel, without any kind of energy. It just kind of moves on its own because of the air that is traveling through it. So we're kind of mimicking a little bit Annie's scientific research. Some things that you might want to try is using different types of lids. You can kind of modify your structure a little bit. If you find another kind of lid, you might want to test that out instead. You can try different amounts of air in your balloon and see if you can get a longer flight with it. You can try out flying your hovercraft on the floor if you feel like it would be a little more fun to do it that way. So go ahead and feel free to experiment with this.
So Annie Easley was not just a brilliant scientist and researcher, but she also gave back to her community by teaching adults about voting rights and workplace rights, and she also tutored kids just like you and shared some of her scientific knowledge with them. So because she encouraged and helped people in her community, she was able to share her knowledge and her passion for science with the people around her. So think about, what are some things that you're really good at and really passionate about? What do you love to do and you know you're really good at it? Now, how can you use what you're good at to encourage or help people around you? Those are some things to think about that Annie Easley would be proud of you for. Now we're going to move on to our third scientist of the day. This is Patricia Bath, and she was an eye doctor and a surgeon and a researcher. Let's learn about her life.
Patricia Bath was born in the 1940s in Harlem, New York. She really wanted to be a doctor, and she worked hard in high school. When she was only 16 years old, she helped out with cancer research as part of a workshop at her high school. She wanted to be a doctor, but most doctors at her time were white men. Most of the medical schools were only for white people. In spite of this, she worked very hard to get a medical degree, and she went on to specialize in eye research. She learned that Black people were affected more by vision problems because of unequal access to medical care. So she started a program in her community to provide free access to eye care. She convinced her fellow surgeons to help with the program by providing free eye surgeries and appointments to people in need. And she went on to do a lot of research to develop new technologies and new surgery for eye care, and made those available to people who otherwise wouldn't really have access to them. So we're going to move on and do our last experiment. So because Patricia Bath worked with vision and eye research, we're going to make our very own optical illusion as our third experiment. It's very easy to construct, and so all that you really need is a piece of paper and some scissors. We're going to use that to
draw an image that is going to be an illusion later on. You need a material to color with, so I have some markers here. You can also use crayons or pencils or a pen, anything that you happen to have on hand. And the last thing that you need is a long item such as a pencil. And you want to just make sure that that's long enough so that we can tape some paper to the top and have some extra room at the bottom for a little step I'm going to show you later. And then we just need some tape to attach that paper to the pencil. Okay, so for our illusion, we're going to need 2 small rectangles of paper. So I have my larger sheet of paper here, and I'm just going to cut that into 4 individual squares because I'm going to make 2 different illusions for you today. And so once we have that all measured out, you're just going to use your scissors to carefully cut along the lines so that you have 4 equally sized rectangles of paper. You can really make as many of these as you want. Today I'm only going to make 2. And we have our second pair of rectangles here, all ready to go. Alright, and then you're going to want to use your drawing instruments to draw a design. So now, it's very important to keep in mind with our optical illusion, here's what it's going to end up looking like in the end. We'll have half of a picture on one of your rectangles, and the other half of the picture will be on the other rectangle. So for my example here, I am drawing a rocket ship, and I'm going to only put in half of what I want my final picture to look like. So as you can see, I'm drawing here. I'm going to draw the outside of the rocket ship on this first half of the paper. And eventually with the optical illusion, it'll make it so that it looks like the 2 halves of the images are coming together and making a single image. So we'll talk a little bit later about why that happens and how it works. But someone like Patricia Bath would study the science of vision and learn about how the eye communicates with the brain to create a message about what you're seeing. So I'm still drawing my rocket ship here, just using a couple different colors to make it a little more interesting. Alright, and I think we are all set to draw the other half of our image. So as you see, I have a rocket ship with a big giant window, but there's no one inside the window. So now we're going to draw that other half of the image. You'll want to make sure that the 2 images are lined up with each other so that the inside of that window is around the same space. So here I am making sure that I have that lined up so that it's the same height and it kind of occupies that space where I have a hole. So I'm going to draw a little astronaut looking out through that window. And it's going to be on this separate piece of paper, but matched up so that it's around the same size as that space I've left in the first picture. So my little astronaut is a cat. It's going to be looking out through the window into outer space. And then we have a little helmet for him. Alright, and I think we are ready to go. So now, just to make sure that you can see, we have one half of the image here and the other half there. They're just about lined up with each other. We're ready to attach them to our pencil. So I have my long pencil object here, and all I'm going to do is use the tape to attach one of the images to the pencil, making sure to leave enough room at the bottom so that I can still hold the pencil with my hand. So I'm just going to use a couple pieces of tape here so that we can attach that picture firmly, and we make sure that the images are facing to the outside. Right? And then we'll put our other half over the first half so that it's making a little sandwich with the pencil in the middle. And I'm just going to put one piece of tape on each of my sides of the paper so that images are firmly attached. Okay, so now we are just about ready to test out our optical illusion. Here we have one side of the picture, there we have the other side of the picture. Let's see what happens. So you're going to want to hold on to your pencil with both of your hands, And you want to move your hands back and forth so that the pencil spins around. And so look very carefully at that image while you're doing it. What do you observe? You should see that little cat face popping up within the window of the rocket shed. And so as I said, we have these two separate images, but because they're moving so quickly, it's sending the message to your brain that they're coming together and forming a single image. I made a second example of this. Here I have a flower pot, and then there's a Venus flytrap coming out of it. So when we rotate that one, you should see that coming together as one picture, and they're forming one image in your brain. So this again is called an optical illusion, because we know it really is two separate pictures, but because they're moving so quickly together, your brain thinks that it's one image. So that's just a little bit of the magic of vision.
So Patricia Bath worked really hard to do what she knew was right, even at a young age, and she didn't let anyone tell her that she couldn't do it. But she didn't just work really hard on her own. She was a good leader and brought other scientists and doctors in her community together to work with her on her project. Have you ever been a part of a good team and worked together to solve a problem? What are some ways that you can use your skills to work together with other people to help others? Thank you all so much for joining us today to talk about these three awesome scientists. If you liked learning today and you want to read and learn more, we have all kinds of free resources just for you that'll help you learn more about our scientists that we talked about today and about some other science concepts. So I got my research for these three ladies today from some books that we have available online in digital format as ebooks. So you can find those right over on our website. I'm going to show you how to do that.
So all three of the ebooks that I used for my research today come from our Overdrive service. And you can find that right on our homepage if you go to PGCMLS.info. You can click on Overdrive. It's right up here on the right-hand corner of the page. Or you can visit pgcmls.overdrive, that's one word, .com. That will also lead you directly there to our ebook platform. So the three books that I recommend for you that mention some of our scientists that we talk about today are the book Woman in Science, 50 Fearless Pioneers Who Changed the World by Rachel Ignotofsky. So this one I did read about all three of our women today, and there's plenty of other fascinating women scientists there available for you. The illustrations of this book are awesome, so it's a great way to learn about some women scientists. You can also read about other women scientists in Trailblazers, 33 Women in Science Who Changed the World. This is by Rachel Swaby. And if you're interested in learning about Black women scientists and others, you can read Little Leaders, Bold Women in Black History by Vashti. So these books and others are available to check out with your library card. Right on overdrive.com, you can read them right on your computer or mobile device.
And make sure to look out for other upcoming programs that we have. We always have STEM at Home every Friday at 12 p.m. And you can also sign up for our Summer at Your Library Imagine Your Story reading program that is going on right now at this very minute. If there's any adults in the room watching, this program is not just for kids, it's for you also. So anyone in your household of any age can sign up for that right over on our website, and it's very easy to do so. Thank you so much again for joining me today. I hope you have a great rest of your day.